Hi guys, so this is the second lesson for accumulation word problems. So pause the video and do the do now. So when I do an integral, so there's a bunch of ways to do this, right? So you could do, okay, helps if I put pen on. You can do the integral from 0 to 8 of 1 plus x to the negative 1/2. Since the derivative of the inside is 1, you don't have to worry about a u substitution or anything. So that's 1 plus x, we add 1 and multiply by the reciprocal from 0 to 8. So that's basically 2, the square root of 1 plus 8. 1 plus x, just kidding, from 0 to 8. So that's 2 times, so if I plug in 8, the square root of 9 is 3 minus 1. So 2 times 2 is 4. Another way that I think about it is, in my head, like one thing that I told you guys to memorize is the derivative of the square root of x is 1 over 2 root x, right? The derivative of this is 1 over 2 root x. So this, the antiderivative going backwards, this is going to be the square root, but I'm supposed to have a 2 in the bottom. Since I need a 2 on the bottom, I need a 2 on top. So then the antiderivative of this, I'm just going backwards. So it's just the square root of x plus 1, and then there's that extra 2 in front. So that's another way of thinking about it. All right, so jumping in, again, remember the integral of our rate is a total amount. And it's the amount of change from A to B. So it's the change from A to B because it's a displacement, right? Like when we talk about velocity, it's the displacement, the change in the distance. If integrating the rate that I drive from home to school, it's the distance I've traveled from home to school. If it's not the total distance, it's the amount of change, right? So keep that in mind when you're doing these problems. So if I integrate the rate of students entering school in the morning from 7 to 9, it's the number of students entering the school between 7 and 9, right? The total number. The change in the number of students that are entering. Because it's just entering, it would be a little different if they were coming in and leaving. I came up with this really dumb example. I couldn't come up with anything better. If J of t is the rate of pulpy orange juice being poured into a strainer, and P of t is the rate that the no pulp orange juice is leaving the strainer, write an equation to represent the amount of juice in the strainer. So I'm going to start, I use T a lot for total. So big T of t equals, now we don't have an initial amount. I'm starting with 0 juice, right? The integral from 0 to t of in versus out. So this is in and then out, right? So J of x minus P of x. It's kind of an awkward problem. It would have made more sense if I did rate of students entering the school and rate of students leaving the school, but you know. All right, so I want you to pause the video, try this whole problem on your own, right? Nothing new here. All right, so traffic flow is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow of a particular intersection is modeled by F. So we only have like an in, like there's no out, right? F of t is measured in cars per minute and t is measured in minutes. To the nearest whole number, how many cars pass through the intersection over a 30-minute period? So one thing you do want to check, it says 30 minutes and we are in minutes. Be careful if that was hours, we'd have to use a half. So to find a total amount, 0 to 30, f of t dt. You don't have to write the whole thing out. It's perfectly good just to write that. And I just plugged this in my calculator and put 2474, and I'm done. B, If the traffic flow, is the traffic flow increasing or decreasing at t equals 7? Give a reason. So traffic flow is this formula, right? F of t is measured in cars per minute. So they're just asking you to find f of 7. F of 7, again, plug that in your calculator. I'll make a calculator video for this, is 80.57597, which is greater than 0. So traffic flow is increasing. C. What is the average value of the traffic flow? So if you're doing these problems for homework, you need to use, like, look it up. Don't just guess. But what is average value? I gave you I said this is a very specific type of problem. Average value is your 1 over b minus a, the integral from a to b of f of x. Like, that's something you just need to memorize. If you're a flashcard type of person, make flashcards, but you need to be able to do this. So it's 1 over 15 minus 10, 10 to 15, f of t dt. I'm going to integrate that, and I get, that's 1 over 5 times 409.496, which equals 81.899. Now, it wants to know what are the units. So when we integrate this, right, the integral of cars per minute is cars. But then we have the over 5, right? This 5 is minutes. So the average value is cars per minute. That's it. And then D. So this is a good, I kind of brought this up. This is one where I do see these every so often, where they're kind of basically making sure that you know the difference between average rate of change and average value. So for average rate of change, that's f of b minus f of a over b minus a, right? So we're going to do f of 15 minus f of 10 over 15 minus 10. And I just used my calculator. I got 1.518. Now, the top, f of 10, f of 15 is cars per minute. And then the bottom is minutes. So this is cars per minute. And you can leave it like that, or it's really just cars per minute squared. It's basically the acceleration. Okay. And that's it. The answers. You know what? I did letter B wrong. I wasn't paying attention. So A is 2474. B, it wanted to know when the traffic flow is decreasing. So traffic flow decreasing, F is the traffic flow. So decreasing would be the derivative, F prime. So you had to find F prime of 7 and show that that's negative, so it was decreasing. My bad. I guess I should have looked up my answers before I kept going. So it's decreasing. I only lost 1 point, though. It's okay. Only 1 point. All right, so average value. Again, just knowing the limits, knowing the integrand, and knowing your answer. And then this is something that you see every so often. When they ask you for units, they'll make 1 point for all the units in the entire problem. So that's something you will see a good amount of time with the way they grade if they ask for units. All right, second one, and then the rest you will do on your own. Pause the video. Again, try it on your own. Hopefully I don't mess this one up. All right. For 0 to 31, the rate of change of the number of mosquitoes on tropical island is modeled by. So this is Again, only one problem here. There are 1,000 mosquitoes on the tropical island. So that gives us an initial, which makes me, we're definitely going to need that at some point. They don't give us that information for no reason. Show that the number of mosquitoes is increasing at t equals 6. So the rate of change of the mosquitoes is just your R. So R of 6 equals, what did I get? 4.438, which is greater than 0. So the number of mosquitoes is increasing. Okay. At time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? So this is asking for the derivative of the rate. So the second derivative of the original function or the derivative of r. So r prime of 6. Again, we're going to use the math 8 to do this. We're not going to take the derivative. Do not try to do a product rule here. This is a calculator problem. Do not do math that is unnecessary. You have a calculator, use it. R prime of 6 is negative 1.913. Since that is less than 0, it is the rate of mosquitoes is increasing at a decreasing rate. Since R prime of 6 is less than 0. So imagine what's happening there is there's more mosquitoes like every, what is this, per day, right? So the first day it's 1,000 mosquitoes. The next day it's 2,000 mosquitoes. The next day, and then, but the rate is coming down. So it's like it goes from 1,000 to 2,000, and then 2,000 to like 2,700. So it went up by 1,000, then it went up by 700, then maybe it went up by 500, 100. So it's still increasing, but the rate that it's increasing is going down. Okay, so that's increasing with like a concavity that's negative. That's what's happening there. According to the model, how many mosquitoes will be on the island at t equals 31? So this is our total, right? So this is, so many of the problems ask this, right? So I like to write total equals my initial is 1,000 plus the integral 0 to 31 f of, it's not f in this one, r of t dt. And I get 964. And that's it. Like, literally, there's no work to be done, guys. This is such easy points. Initial plus the integral over the period of time. That's all you need to remember. The initial is important, though. All right, letter D. To the nearest whole number, what is the maximum number of mosquitoes? And this is why I like to make that form. I like to write out the total equals. So total, that's like my equation, equals 1,000 plus the integral from 0 to t this time of r of t dt. So this represents the number of mosquitoes at any time. If this is the total number of mosquitoes at any time, how do I maximize that number? Well, to find a maximum, you take the derivative. The derivative of 1,000 is 0. And when you take the derivative of an integral, you replace. Oh, you know what? I made a mistake. It's not a huge deal. I don't think that oops, that's not the eraser. They don't actually take off for that, I don't think. I can't erase the pen. It's not letting me erase the pen. You're supposed to technically put X here. It's not the biggest deal in the world. I don't think they wouldn't take, I don't think they actually take off for that, but R of t. So t prime equals r prime of t. And then we want to know when is the derivative equal to 0. So when does 0 equal r of t? So I used the calculator, and there's two answers here. So I have 8.1276, and I labeled that A on my calculator. I renamed it, and then I got t equals 23.5619, and I labeled that B. So because I'm finding over an interval, I'm finding the absolute max. So for absolute, I'm going to find t of 0, t of 31, t of A, and t of B. And if you actually label these as A and B, you can write that. You don't have to actually write it out. So t of 0 is 1,000. T of 31 we found in part C. Part C was 964. A, it's 1,000 plus the integral from 0 to A, r of t dt. Plug that in, and I get 1,039. And then 1,000 plus 0 to B, r of t dt. And I get 842. And it wanted to know, to the nearest whole number, what is the maximum number of mosquitoes? Well, maximum number of mosquitoes was 1039. And this is my work, right? Showing all of these and all of this, that's all the work you need, right? Okay, so then the second two problems are for you. They are also calculator based. Please do your work, send it to me. I will post the video of how to do them tomorrow. Have a great day, guys.